Welcome to Narayan PO's online classes. So in the last video, we have discussed level 2 questions up to the 10th question. Clear? So 11 questions once you see. Question number 11. Clear? Pick up the incorrect statement. Clear? So N2 has greater dissociation energy than N2 plus ion. Yeah, whenever they have given greater dissociation energy and dissociation energy bond length, if they give, you have to calculate the bond order. I already said the relation. We have already discussed the relation between the bond order, bond dissociation energy, bond length. Clear? So whenever the question is there based on bond dissociation energy or bond length, you must calculate the bond order. Clear? So you know how to calculate the bond order. Bond order formula I have given. First you have to write the electronic configuration sigma 1 s2, sigma star 1 s2, sigma 2 s2, sigma star 2 s2, like. Clear? So for up to the 14, electronic configuration is different, and greater the 14 electronic configuration is different. Clear? But every time writing the electronic configuration, and sometimes you may forget and which configuration you have to write in the examination. So that's why simply I will give one shortcut to you. Clear? So based on that shortcut, we can easily calculate the bond order without writing any electronic configuration. Clear? First of all, suppose N2 is there. Usually how we will calculate? N2 if it is there. See what? N2 means how many electrons are there here? 14 electrons, because one nitrogen will have 7 electrons and 2 nitrogen means we will have 14 electrons. 14 electron means how we have to write? First of all, sigma 1s2 and sigma star 1s2 and sigma 2s2, sigma star 2s2. It is 14 or less than 14 means first it will come pi 2px is equal to pi 2py. Clear? Up to here 1, 2, 3, 4, 8, 9, 10, and again another electron. Here up to here what it is? 1, 2, 3, 4, 5, 6. 6 2s are 12. And next it will come, sigma 2p z, and here 2 electrons. This is actually electronic configuration. Clear? Then bond order you have to calculate. What is the bond order? Of into Nb minus Na, that we have already given. So how to calculate here? Of Nb means electrons present in the molecular orbital. Sigma here 1, 2, 3, 4, 5. 5 2s are 10. Antibond means star. Here 2 and here 2, 4. So what you will get from here? 6 by and here 2 and 3. What is the bond order here? And the bond order is 3. Means nitrogen and nitrogen, between the 2 nitrogen. What is the bond order here? How many bonds will be there? 3. This is usually we calculate. But in the competitive examination, if you do all these things, and it takes much time. So that's why here I am giving one simple formula, characteristic bond order. Bond order is equal to, clear? So n minus 8 divided by 2. This is for n, clear? Is equal to n to 14 electrons. If the number of electrons are in between 8 to 14, then you have to use this formula. Clear? And bond order, second one. Another one is 20 minus n divided by 2. This is n is 15 to 20 electrons. N means number of electrons. N is what you know here, number. This is the shortcut. You need not to write here any electronic configuration. Just calculate the number of electrons and see whether the electrons are 8 to 14 or greater than 14. And use this one. See now, if I calculate for this is N2. N2 how many electrons are there? 14. 14 means you have to use this formula. Clear? Use this formula. What it is? Bond order is equal to 14 minus 8 divided by 2. Then what you will get now? 6. 6 by 2 how much now? 3. Are you getting same or not? Here also we got the same. But you have to write here, you need not write. So use this formula, very important. And this is clear? So now I have calculated for N2. N2 plus if I calculate, N2 plus means, you know, N2 how many electrons are there? N2 14 electrons. N2 plus means you have to remove one electron. Remove one electron means how much? 13. Calculate the bond order here. Bond order is equal to 13 means 8 to 12, 14 electrons are there. You have to use here 13 minus 8 divided by 2 and 5 by 2 and 2.5. Clear one? So bond order for N2 is 3. And N2 plus is 5. So greater the bond order and greater will be the dissociation energy. 3 bonds are there here, 2.5 bonds are there. You have to break, put the lot of energy there. So that's why first one is correct. O2 has lower dissociation energy than the O2 plus. Same, calculate the O2 bond order here. O2 means how many electrons? 8. Oxygen means 8. 8 into 2, 16 electrons will be there here. 16 electrons means which one you have to use? You have to use this one, means electrons in between 50 to 20. You have to use this one. 20 minus and 16 divided by 2. How much money? 4 by 2. 4 by 2 means how much? 2. Bond order is 2. If you calculate here, O2 plus means how many electrons? 15 electrons. Same formula you have to use. 20 minus 15 divided by 2. So 5 by 2. And here what is 2.5. Bond order is for O2 plus greater than O2 means O2 plus needs bond addition means more bond dissociation means you have to supply a lot of energy to break this bond. So that's why O2 has lower bond dissociation energy than the O2 plus. Correct only. Next one. Bond length in N2 plus is less than N2. You know that bond order is directly proportional to bond dissociation energy, and this is bond order against another one. Bond order is inversely proportional to bond length. Now third one they are asking bond length in N2 plus is less than N2. N2 plus where we have got this is N2 plus. This is 2.5 and N2 how much? 2 and N2 is 3. So which one will have bond length? Bond length N2 plus is greater than N2 because bond order is less for N2 plus. Bond length will be greater. So that's why N2 plus has greater bond length than the N2. So that option is the wrong option. Clear? So this is option 3 is the correct one. Next one. If you see the 12th question number 12. See the 12th question number 12. They have given here bond angle. Question based on which one here? Bond angle. See what is the bond angle they mentioned. They have given H2O and another one is Cl2O and another one is F2O. Clear? So for which compound bond angle is? Means they are asking write the R of bond angle for these compounds. Clear? If you know that for all these compounds the shape is bell shape. Clear? I already mentioned oxygen whenever it is forming two bonds it will have two lowercase. Clear? So this is the shape of the molecules. Clear? Central atom is which one? Oxygen only. Clear? You know that in all cases which one has the bond angle, which one has the greater bond angle. See now, if you take in this case oxygen and fluorine, fluorine is more electronegative, so that's why these bond electrons are close to which one here? Fluorine. So that's why the bond bond pair repulsions will be less. Why? Because these fluorine means bond pair electrons, the distance between the two bond pair electrons are large. If bond pair electrons distance is large, then repulsions will be minimum and the repulsions are less. Means these two bonds will come close till they experience the repulsions. Because and here you know the distance between the bond pair electrons are large, so repulsions will be less. Means there will be no repulsions. So that's why these two fluorine atoms come close till they experience the repulsions. Come close means what will happen? Bond angle will be less. Got my point here? Means as I already mentioned previous, and as the surrounding atoms electronegativity increases, bond angle decreases. Clear? In this case you see, here oxygen is more electronegative than the hydrogen. So that's why these bond pair electrons are close to what it is, oxygen. Then here the distance will be less between the two bond pairs. Distance less means and repulsions will be more. When repulsions will be more, and to avoid that repulsions, and these two bond pairs means bond pair electrons move away from each other, then bond angle here increases. Bond angle decreases, bond angle increases. Coming to here, OCl2. Clear? You got the clarity between these two, but here you see. In this one, oxygen and chlorine, which one is more electronegative? Almost, oxygen is more electronegative, but chlorine is not very less electronegative. So that's why these are not very close to oxygen. They are, and here like this. But and here these two chlorine atoms are bigger in size. When they are bigger in size, there will be a repulsion here. Why? Because this chlorine atom is having what it is, 3 lone pair of electrons, and this chlorine atom is also having 3 lone pair of electrons. What will happen here? And they are bigger in size. Bigger in size means they are coming close. When they are coming close, what will happen? There will be a more repulsions. There will be, because here lone pair repulsions between the chlorine atoms. So lone pair repulsions are very large. So that's why they are experience more repulsions. To avoid that, these two bonds will move away from each other. Clear? So that's why in the Cl2O bond angle will be greater, and after that where it is, H2O, where it will be the least, OF. This is the what is bond angle. That is question number 12. Clear? Coming to the question number 13. So option 2 is the so hybridization in C3O2. C3O2. What is the, if you know the formula, then this structure you can easily calculate the hybridization. This is the structure of this compound, C and C double bond O and double bond O. This is the structure. Then what there are some hybridization. Hybridization means number of bond pairs plus number of lone pairs. That is the hybridization. How many bond pairs are there? Suppose we will say 2 bond pairs are there, 1 lone pair is there, and total 3. We will say it is a sp2. Clear? So means hybridization, how we will calculate? Number of bond pairs plus number of lone pairs. But if you see here carbon, any carbon you take, this carbon if you take, clear? So here bond pair, sigma bond, this is sigma, one is pi and one is pi. You know that carbon, when it is forming 4 bonds, it will not have any lone pair. Clear? So that's why it is having only 2 sigma bond. Pi bond we never considered in the calculation of hybridization. So that's why there are 2 sigma bonds. Which one is one? There are 2 bond pairs and 0 lone pairs. So what is one? 2 means what it is one? Sp hybridization. Clear? Hybridization is sp. So and the cyanogen has a shape and structure. Cyanogen means this is Cn and here and Cn. What is the shape here? Linear. The shape of this molecule is which one here? Linear. Clear? So because why it is linear? Because this carbon is having which hybridization? Sp hybridization. Why? Because how many bonds this carbon? I have calculated for this carbon. You can calculate for any carbon, you will get sp only here. If you take this carbon, this is 1 sigma bond, this is 1 sigma bond, 2 pi bonds. Pi bonds never be considered in the hybridization. So that's why what is the hybridization of these carbons? Sp hybridization. Sp hybridization means what is the shape? Linear. So that is the shape of the organism here. Next one, question number 15. Coming to the question number 15. Ethanol has higher boiling point than diethyl ether, though they have same molecular weight. This is due to ethanol. What is the formula of ethanol here? The formula of ethanol is CH3CH2OH. This is the ethanol formula. Clear? And dimethyl ether. Dimethyl ether means dimethyl. Methyl and O, and this is O. This is a dimethyl ether, and this is ethyl alcohol. OH is there, alcohol. They are having, both are having almost molecular mass. If you calculate, almost have the same molecular mass, but ethanol is having high boiling point than the ether. What is the reason they are asking? Clear, my dear? You know that, and ethanol molecule can form the hydrogen bonding, intermolecular hydrogen bonding, whereas you know dimethyl ether do not. Clear, no? It cannot. Why? Because means you see here in this one CH3, CH2 and OH. I will take another molecule and OH, C2, H5, or I can write CH2, CH3. If I write like this molecules, what I can do from here? You see in this case, what will happen? Hydrogen is attached to highly electronegative atom, and here also oxygen is there, highly electronegative atom. There is a hydrogen bonding. Clear? Not only this, if you keep on writing, if I write another molecule here, and there is a OH and C2H5, so there are so many. If I write here another one, keep on, and means more the ethanol molecule and more number of hydrogen bonding exists. Clear? So this is a good one. If you take this one, is there any hydrogen bonding chance here? Yes, there is a. In this one, oxygen is there, but next one is here hydrogen is not attached to the any highly electron. This hydrogen is there. Hydrogens are there CH3, but these hydrogens will not participate in the hydrogen bonding. Why? Because hydrogen to participate in hydrogen bonding, that hydrogen must be attached to highly electronegative atom, that is oxygen, nitrogen or fluorine. But here it is attached to carbon less electronegative. There is no, what it is here? Hydrogen bonding. You see here hydrogen bonding means some extra bonds these are. Hydrogen bonding means what is it? If molecules are there, these are some extra bonds. Extra bonds are there. Boiling point means what it is? And if it is there liquid, you have to supply the heat energy, then it will be converted into vapor. Clear? So means you have to break these bonds. Clear? Some extra bonds are there. Extra bond to break. Extra energy supply. The extra heat energy supply, that we will call as what it is here? Boiling point. Means, and extra bonds are there, automatically boiling points will increases. Clear? So that is why, and here the reason why ethanol is having high boiling points means due to the hydrogen bonding. Clear? So this is question number 15. And coming to the question number 16. See what they have given. And the ethanol has arranged the following in order of decreasing boiling point. So some compounds they have given. So they are asking to write the and boiling point decreasing order. Clear? Remember, whenever hydrogen bonding present, then boiling points increases. Clear? In which case, intermolecular hydrogen bonding. Intermolecular hydrogen bonding existed. Automatically, what is my boiling points increases. Keep that point in your mind. Clear? Means I can directly say boiling points are directly proportional to intermolecular hydrogen bonding. Intermolecular hydrogen H bonding. Hydrogen bonding. You remember this point. Okay? And also another important point, boiling points are directly proportional to the polarity. Boiling points are which one? Directly proportional to the which one? Polarity. Another one is boiling points are inversely proportional to branching. Clear? And branching increases, boiling point decreases. Clear? If no branching, boiling points are indirectly proportional to the, what is you can say, non-branching molecules. Branching is not there. Then means linearity is there. Clear? Means for that one boiling points you need. These points you have to remember. Clear? So why branching increases, boiling point decreases? And that we have discussed. I have already discussed here, intermolecular hydrogen bonding exists, then molecule will have high boiling point. Just now only we have seen polarity increases, Polarity increases means what will happen? If you see, suppose if I say any molecule HF if I take, what is my here? HF if I take. Clear? So in this one, fluorine is more electronic than, and it will take the bond electron towards it. Then what will happen? H is plus and F is minus. If poles are there, then what will happen? Another molecule, if any molecule means between these two, hydrogen and fluorine, attractions will be very strong. If attractions are strong, polarity means poles generated. When poles generated, attractions between the positive pole and the negative pole will be existed. Clear? Then what it is, and poles are there, attractions become very strong. If attractions become strong, to break those attractions, you have to put lot of heat energy. So automatically boiling points increases. That is the concept. Clear? Next one. Boiling point branching increases. Suppose I will say one compound. This again we will discuss in the organic chemistry. If branching, suppose I will write here one compound. CH3, CH3, CH2, CH2, CH3. Clear? And 5 I have written. This is molecule. Next one. Same molecule I will write in this way. CH3, CH3 and CH2, CH3. 1, 2, 3, 4, 5, 6. So here this is. Clear? You see, this is a molecule, no branching, straight line. Clear? But here, this is one is straight line, but here there are branches. Clear? You know, if there is no branching and this is the surface area of this molecule. Clear? If I write another molecule, same molecule, because in this one CH2, clear? CH2, CH2, CH2 and CH3. These are molecules. These are non-polar molecules. Not in the non-polar molecule, what will happen here? There will be a attractions. Van der Waals force of attractions will be called. What we will call these are Van der Waals forces of attractions existed along the length of this surface area. Clear? These are Van der Waals forces. Non-polar means which forces existed here? Van der Waals forces. Clear? And if you see this is, and this is surface area. Compared to this surface area, what is one? Increasing. If I write another molecule CH3, CH3, CH3 and CH3 among this molecule, you see my here? This is surface area of this molecule. Here also non-polar. Non-polar means which one will exist in my here? Van der Waals forces existed. But here, you know, and surface area is less. So, and here Van der Waals forces existed along the short length of this molecule. But here you see, if there is no branching, surface area increases, surface area increases, Van der Waals forces also what is increases. Van der Waals forces increases means some extra bonds, these are increases. And then automatically extra bonds are present, automatically boiling point increases. This is the concept. And based on this concept, we have to do the question number 16. See the question number 16. What they have given? One is N-butane. N-butane means CH3, no branching. N means there is no branching. It indicates no branching. Clear? This is N-butane. 4 carbons are there. And second one is, this is the first one. And second one they have given here is N-butanol. N-butanol. This all we will study, no problem, because in the organic chemistry when we start, and we will study there. This is butanol. But means 4 carbons. OH means all. Clear? Butanol. Butyl chloride. N-butyl chloride. CH3, CH2, CH2, CH2 chloride. This is instead of OH we have to write chloride. Next, isobutane. What is the formula of isobutane? Means CH3 and CH3H and CH3. This is isobutane. Then they are asking, clear? What is the they are asking what is the order of boiling points. Clear? See now. In this one, if you take in all the cases, you know, in this one what will happen? This molecule is a polar molecule. Why polar? Because oxygen is highly electronegative atom. So that's why it can take the electrons and convert it into negative charge, and it is a positive charge.
and it from also carbon. If carbon gets the positive charge, oxygen gets the negative charge. Here what is there? Poles are generated. I already mentioned when polarity increases, boiling point increases. Here polarity one is the reason, and also this molecule can exhibit the what it is hydrogen bonding. Just now previously we have discussed hydrogen bonding. Means here two factors helps to increase the boiling point. Got my point here? One is polarity. This molecule is a polar molecule. Polar molecules are there, you know, and bond is strong, and then automatically boiling point. When bond is strong, boiling points increases. And along with that polarity, which bonds are present here? Hydrogen bonding. Hydrogen bonding also helps to increase the boiling point. So these two factors, and here increases the boiling point of this molecule. But here you see, this molecule is a polar. Why? Because chlorine is more electronegative than the carbon. Carbon is losing electron. Chlorine is gaining electron. Molecule is a polar. But what will happen here? There is no hydrogen bonding. So here only polarity increases the boiling point. So that's why 2 comes first, and after that which comes first? Second one. Third one comes second. And these are non-polar molecules. These are which one here? CH3, CH2. Why non-polar? You may ask. Sir, hydrogen and carbon electronegativity difference is there. You know, carbon and hydrogen electronegativity difference is very small. Almost carbon and hydrogen will have same electronegativity. So that's why, and these molecules are non-polar. Non-polar molecules have less boiling point than the polar molecules. Got my point now? So that's why. So between these two now you have to find out which one is having more boiling point. Here branching increases. Branching increases, boiling point increases. There is no branch. So next 1, and what we will get now 4. So this is the what it is one option. Next one, 17th one. So which of the following compound would have significant intermolecular hydrogen bonding? 17th one, you see one. They are asking intermolecular hydrogen bonding. You already know any compound to participate or to exhibit intermolecular hydrogen bonding. You know the molecule should have one hydrogen which is attached to highly electronegative, and there should be another one highly electronegative atom. So that is the concept. Clear? See now they have given HF and CH3OH, and the next one is N2O4 and CH4. Which of these molecules will exhibits the what is my intermolecular significant intermolecular hydrogen bonding is present? You know there is no hydrogen bonding because there is no hydrogens here, but carbon and hydrogen is there. Hydrogen is present, but hydrogen is not attached to the highly electronegative atom. So this hydrogen will not participate in the hydrogen bonding. See here, hydrogen is there. Hydrogen is attached to highly electronegative atom. So that's why it can participate in the hydrogen bonding. If I write another one molecule here, same molecule, intermolecular hydrogen bonding. If you take this hydrogen attached to highly electronegative atom, so it can participate. It will participate hydrogen bonding with highly electronegative atom like oxygen, fluorine, and nitrogen. So there is a chance of hydrogen bonding. HF also, HF is highly electronegative atom. So here fluorine is a highly electronegative atom. Hydrogen is present. So that's why this hydrogen attached to highly electronegative atom, and also here a highly electronegative atom is present. So there is a chance of hydrogen bonding. So that's why both HF and CH3OH will have significant intermolecular hydrogen bonding. So that's why 17th option 3 is correct. Clear? Next one. Coming to the question number 18. H2O2. Clear? Very important question this is also. H2O2, H2S. Next one is H2O, HF. Clear? Correct order of decreasing extent of hydrogen bonding. Where hydrogen bonding is highest, order they are asking. Clear? And you know what is hydrogen bonding? Hydrogen bonding means it is attractive forces between the hydrogen and the highly electronegative atom. Clear? So, if highly electronegative atom is there, then what will happen? There, charge density will be very, very high. And here, you know, hydrogen and fluorine. Fluorine is highly electronegative atom. So that's why it takes the electrons and it creates the much positive charge here. And fluorine is having the highest negative charge density, highest positive charge density when hydrogen is attached to, and you know, highly electronegative atom. Then what is here? Hydrogen bonding is directly proportional to the electronegativity. Greater the electronegativity, greater will be the charges on the fluorine and means highly electronegative atom and hydrogen atom. And greater the charge density, greater will be the attractive forces, and that attractive forces will be considered as a hydrogen bonding. Clear, ma? So that's why hydrogen bonding is directly proportional to what is here? Hydrogen, strength of hydrogen bonding. You know, strength of hydrogen bonding is directly proportional to the highly electronegative atom. Means electronegativity of atom increases. What will happen here? Hydrogen, strength of hydrogen bonding increases. Got my point here? That is why, because greater the electronegativity, greater the charge density on the respective atoms. So greater the charge density, greater will be the attraction. At that attractions will be considered as a hydrogen bonding. Now, if you see in this one, oxygen, sulfur, and here what is there? Here oxygen and here fluorine. Which one is the most electronegative element here? HF means fluorine. Fluorine is most electronegative means, and bond strength of hydrogen bonding will be highest in HF. So that's why first what will come here? HF. Oxygen and sulfur if you take, which one is highest electron? Second most electronegative element is oxygen. Then what we have? Two are there. One is H2O2 and another one is a H2O. If I take H2O, if I take what is here? H2O. This is clear, no? Oxygen is more electronegative. So this bond electron will shift towards oxygen. Oxygen is gaining electron means negative charge. This is what is positive charge. And here positive charge and here negative charge. Total how much negative charge is there here? There is 2 negative charge. Greater the charge and greater will be the, suppose if I write here H plus and O and here H plus and here 2 delta minus partial charge. Delta indicates here partial charge. Clear? So now greater the charge, greater will be the attractions. Clear? So that's why in this oxygen, in water, oxygen is acquired. So what is here? 2 negative charge. Greater the charge, and here what is positive charge. If any one of the charge is greater, attractions will be strong. If you take H2O2, what is the formula of H2O2? This is, if I write H and here H. Clear? But if you say this is what is positive, but this oxygen is negative and this oxygen is negative, this is positive. Means, but in this oxygen, one oxygen, see the one oxygen here, 2 negative charge, but here 1 negative charge. Compared to here, negative charge is, means charge is less, 2 negative charge, 1 negative charge. 1 negative charge means charge is less, then automatically attractions also will be less. If I write another hydrogen here H and here OH, then here what is positive charge, and this is a hydrogen bond. But here positive charge, negative charge, positive charge attractions here. But here 2 negative charge, positive charge attraction. Greater the charge, greater will be the attractions. So that's why compared to the H2O2, H2O bond, hydrogen bond strength will be greater. Okay? At last, which one will come? H plus, because it is less electronegative atom. So that's why, you know, and these in this case we will observe least hydrogen bonding. Clear? So that is one. Now, what is the bond order here? Which one comes first here? HF, bond strength will be greater, and the next will come H2O2, next will come H2O2, here H2O, H2O2, and last will be H2. Yes, and this is the question number 18. Next one. Means option, which option is correct one? Option 3 is the correct one. Clear? Coming to the question number 19. Clear? What is the question? So a simplified, application of molecular orbital theory, hypothetical molecule OF would give the bond order. Means they are asking OF bond order. They are asking. You see how much? Means if you write here electronic configuration, everything, it will take so much time. I have given one shortcut. Use that one. Oxygen how many electrons? 8. Fluorine how many electrons? 9. Fluorine how many electrons? 9. Okay? Oxygen is 8. Total how much? 17. Total how many? 17. 17 means greater than means 15 to 20 means what the bond order we have to use here? 20 minus n divided by 2 means 20 minus 17 divided by 2 means 3 by 2. How much bond order? 1.5. That is the question number, what it is here? 19. Clear? Next one. Question number 20. So which of the following contains electrovalent and covalent bonds? Electrovalent and covalent bonds. Electrovalent means which bond? Ionic bond, and they are asking covalent bond. I already said one means criteria for the ionic bond. Ionic bond is formed between the metal and non-metal. But one exceptional case is there, that is ammonium salts. Clear ma here? Exceptional case, because there both are non-metals only, but it will show the ionic character. What is that one ma? Exceptional case. All bonds between the bonds between the metals and non-metals we will consider as a ionic. But one exceptional case is there, that is ammonium salts. If they give any ammonium salts, and in this ammonium salt there will be an ionic bond. Clear? See what it is means, how it will be NH4 plus, and what it is here? Cl minus, positive, negative. Which bond here? These attractions is considered as a ionic bond. But sometimes they will ask how many bonds are, means how many types of bonds are there. There means we have 3 types of bonds. One is, and because here you see charges, electrons are transferred towards which one? Chlorine. If it is, one is gaining electron, positive charge, another one is negative charge. Electrons are transferred towards which one? Chlorine. So it is which bond? Ionic bond. But in this case, ammonia, if you see, hydrogen, and hydrogen, these bonds are which bonds? These all bonds are covalent bonds. Which bonds? These are covalent. And now, fourth bond is formed. Nitrogen is forming how many bonds here? 4 bonds. Nitrogen has to form how many bonds? 3 bonds. Fourth bond, when it will form? When it donates its lone pair of electrons to H plus. And a pair of electron is donating. Nitrogen is losing electron. Hydrogen is gaining electrons. Then what you will get to see? Hydrogen, and here there will be hydrogen positive charge. That is only NH4 plus we will consider. What my point here? You see, 3 bonds are there. Fourth bond, nitrogen, when it will form? When it donates its lone pair of electrons to electron deficient species. Nitrogen is losing electron. Nitrogen gets the positive charge. Hydrogen is gaining electron. Hydrogen should get the which charge? Negative charge. Already hydrogen is having which charge? Positive. Same atom having both the positive and negative. Positive and negative charge will be neutralized. So you will get here hydrogen. And this bond we will call as a dative bond or coordinative bond. Clear? So NH4 molecule will have how many types of bonds? Means we have to say the answer 3 types of bond. One is ionic bond, and another one is covalent bond. Last one is coordinate bond. Clear? So your option should be what it is here. 20th question option is NH4Cl. Clear? Next one. 21. Question number 21. If you see the question number 21, The types of bonds are present in N2O5. N2O5 previous we have discussed. Remember question number 21. Previous we have discussed N2O5. What is the N2O5 structure? This is N2O5. Clear? Previous we have discussed, so that's why I am writing directly. This is N2O5. Clear? How many more types of bonds are there? These are oxygen and nitrogen. Both are non-metal. Non-metal bond means which one? Between the two non-metal, the bond is covalent bond. These all are. Which bonds are here? Covalent bonds. Covalent bonds. Clear? But these two are which ones? Coordinate bonds. Coordinate bonds. So how many types of bonds are there here? Two types of bonds. Clear? And which of the following exhibit hydrogen bonding? Direct question here. Hydrogen bonding, where it will be? Must be oxygen, fluorine, nitrogen compound should be there. To that atoms, hydrogen should be added. So which one should be your answer? Option 3, because nitrogen is there in the option 3, that is only highly electronegative atom, and that molecule only involved in the hydrogen bonding. Clear? Next one. And 23 question, it is irrelevant. I already mentioned some questions are there, irrelevant questions. Clear? And the 23rd question, we will study in the second year. Second year means, 15th group elements will be there. There we will study that question. We just leave it. Clear? Next one. Coming to the 24. Clear? So, a state of hybridization. Hybridization they are asking. What is the hybridization for which molecules they are asking? BCl3 and SF4. I already mentioned shortcut how to find out the hybridization. Clear, Maya? You know that in this case, boron. Boron means what is it? Boron belongs to third group or 13th group. Third group we will consider how many electrons we have, right? 3 electrons. And chlorines, how many are there? 3 chlorines are there. Each chlorine need 1 electron from the boron to form a bond, because boron give 1 electron. This is electrons for which one? Boron. Chlorine give 1 electron. Boron gives 1 electron. This is and form a bond. Clear? And these bonds are there. Bond means with 2 electrons it will form. So these 3 bonds we will consider as a sigma bonds, and these 3 bonds we will consider as a bond pairs. 1 bond means how many pairs? 1 pair, 1 electron pair. 3 bond pairs. Is there any lone pair? 0 lone pair. So 3. 3 means what is the hybridization? sp2, and here 1 plus 2, 3, that is sp2. Clear? This is the hybridization. Next, coming to the SF4. Sulfur belongs to which group? Oxygen, sulfur belongs to which group? 6th group. 6th group means how many electrons you have to write? 6 electrons you write. 1 and here 6 electrons you write. Clear? And how many fluorine atoms are there? 4 fluorine atoms means each fluorine atom need 1 electron from the sulfur to form how many bonds? 4 bonds. So that's why these all are which bonds? Sigma bonds means bond pairs. How many electrons left here? 2 electrons. That we will consider as a 1 lone pair. So 4 bond pairs are there and 1 lone pair is there. Total how much? 4 plus 1? 5. 5 means what you have to write? First S. Next P3 because P are equal 3. 3 plus 1 4. And next which one you have to write? D. That is the hybridization. One is sp3d hybridization and another one is sp2. Clear? So your option should be option 1 is the correct one. Coming to the question number 25. Clear? See the question number 25. The bond order depends upon the number of electrons in the bonding and anti-bonding orbital. Which of the following is correct? I already said bond order can be positive, negative, clear, and fractional. So your option should be, it can assume any value positive, negative, integral or fractional including 0 also. Bond order can be 0, bond order can be positive, bond order can be negative, bond order can be, what it is here, fractional also. So your option should be 4. 26th. In the formation of N2 plus from N2, the electron removed from which orbital? For this one, you have to write the electronic configuration. N2 plus means N2 you already know. What is the N2 electronic configuration? Total how many electrons are there? 14. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next what it will come? Pi, because 14 electrons means pi 2px is equal to pi 2py and sigma 2pz. Here 2 electrons and here 2 electrons. 1, 2, 3, 4, 5, 6, 7. 7 4 are 14. Now N2 is, which one has to form here? N2 plus should be formed. N2 plus should be formed means what? You have to remove one electron from the N2. Remove the one electron. Which you have to remove the electron from which orbital they are asking. We already know we will remove electron always from higher energy orbital. Which one is the last orbital here? Sigma 2 is this is the higher energy orbital. You have to remove the electron from here, then you will get 2p1, and that is the electronic configuration of N2 plus. So we are removing electron from which orbital? Last orbital, that is highest energy orbital, 2pz. So sigma 2pz. Which orbital we have to remove? Sigma orbital. So option 1 is the correct one. Clear? So next one. The type of bond present in CuSO4 5H2O. Clear? CuSO4 5H2O. Clear? This is a, we will consider as a complex compound or coordinate compounds. In the second year coordination compounds are there we will study. But simple, what it is there, and here copper and sulfur. Copper is a metal, sulfur is a which one? Non-metal. Metal and non-metal bond should be which one? Ionic bond. Ionic bond. And you know sulfate, SO4 2 minus. Copper plus 2, SO4 2 minus. So the bond between the sulfur and oxygen should be what it is, man? Sulfur and oxygen. Because both are non-metal. Sulfur and oxygen bonds are oxygen and hydrogen bonds. Which one those are? Those are covalent bonds. Those are which one? Covalent bonds. Bond between the metal, non-metal and non-metal covalent. But here 5 hydrogen water molecules are there, and each water molecule and make a, this is actually CuH2O, and here 5 times and SO4. Like that this molecule will be there. Means water molecule are connected to which one? Copper. Means here these will be called as a ligands. These will be called as what is called ligand. They donate pair of electrons to metal and form a bond. Donating pair of electrons to metal forming a bond means which one it is? It is a coordinate bond. 5 coordinate bonds will be there. So that we will study in the second year. But how many bonds are there here? One is ionic bond, that is copper and sulfur, metal and non-metal, ionic bond. And if you take the bond between the sulfur and oxygen, non-metal bonds means covalent bond. And here it will form the water molecule, make a bond with the copper by donating its pair of electron. If a bond formed by the donation of pair of electron, we will call as a coordinate bond. So that's why totally how many bonds will be there here? Total 3 types of bonds. So what should be your answer here? Your option should be 4. Clear? No? Next one. Question number 28. Polarizability of the following compound and ions are. I already mentioned polarizability, polarizing power. Polarizing power belongs to cation. Polarizability belongs to anion. As the size of anion increases, polarizability increases. Clear? As the size of cation decreases, polarizing power increases. That I already mentioned. So that's why as the size increases, means if they have given iodine and here I minus, Br minus, Cl minus, F minus. Clear? Fluorine, chlorine, bromine and iodine, fluorine, chlorine, bromine and iodine. As you are moving along the group, size increases. So this is the iodine has larger size, so that's why it will have greater polarizability. So your option should be option 1. Question number 29. 29 they are asking hybridization. HCF4 hybridization they are asking. You already know how to calculate. Xenon belongs to which group? 8 group. 8 group means how many electrons you have to write? 8 electrons you write. Fluorine, how many fluorines are there? 4 fluorine. Each fluorine atom need 1 electron from the xenon to form a bonds. Clear? So left one we have to taken as a base. So these bonds are there, that will be called as a bond pairs, and these will be called as a lone pairs. How many bond pairs and how many lone pairs? 4 plus 2, and here total 6. 4 bond pairs, 2 lone pairs, total 6. 6 means what more? sp3 d2, 3 plus 2 5, 5 plus 1 6. This is the definition. Clear? Next one, 30th question. How many sigma and pi bonds are there in salicylic acid? And the 30th question, salicylic acid formula is, you will study this one in the second year. This is salicylic acid. Clear? Here what will be there? There will be hydrogens on the benzene. This is salicylic acid. Clear? You know how to calculate the sigma bonds and pi bonds. Clear? Will you do one? So here one double bond is there, one sigma and one pi. Here double bonds are there. Calculate. Here how many sigma bonds are there? 1, 2, 3, 4, 5, 6. 6 sigma bonds. And this is also 1, 2, 3, 4, 5, 6. And 6 sigma bonds. And here 1, 7. And here 1, 8, 9, 10. What my bond here? So means totally, see here 6 are there. I will write 1, 2, 3, 4, and here 12 plus 4. How much more here? 16 sigma bonds. And here this is a pi bond, pi and pi and pi. So there are 3 pi bonds. Total 16 sigma bonds, and yeah, this is one pi bond is there. This is one pi bond. 1, 2, 3, and 4. Total how many bonds are there? 4. 16 sigma bonds and 4 pi bonds. Coming to the question number 31. When 2s, 2s, 2p, 2p, 2s, 2p orbital overlap, the bond strength decreases in the organ. Clear? Very important this is. More the directional and stronger will be the bond strength. Clear? What it is? Greater the means if you take the directional. Greater the direction means you can simply say more the directional of orbital, and greater will be the strength of the bond. Clear? Which orbital is more directional? Now they have given two options here. 2s, 2s they have given, 2p, 2p they have given, and 2p, 2s also. Clear? You see now. You know s orbital are non-directional. Spherical shape. S orbital are non-directional. But p orbitals are directional. P orbital what is known here? Directional. So both the p orbital, 2p, 2p, p orbitals are directional means extent of overlapping will be more. Extent of overlapping will be more, then bond will become stronger. So that's why in this case, you know which one is more directional? P orbital. So 2p, 2p is more directional. So the bond formed by the 2p, 2p is will be very, very strong. And next, which one is directional? Here 1, 2p, one directional, one non-directional. So next one will come 2p, 2s. But here non-directional. Non-directional means, you know, overlapping, extent of overlapping will be very less. So the bond formed is weak bond. So what will be the order here? This is the clear. So that's why option 2 is the correct one. Clear? Next one. And 32 question we have discussed how many sigma bonds and pi bonds are there in the tetracyanoethylene. Not the same compound, not we have not discussed, but I will write the just structure of the compound. You calculate how many sigma and pi bonds are there. Clear, ma? So tetracyanoethylene. Tetracyanoethylene. Ethylene means C double bond C. Tetracyano, 4 cyanide groups will be there. And here, and this is cyanide, and this is cyanide. Calculate how many pi bonds and sigma bonds will be there. And 9 sigma bonds and 9 pi bonds should come, and just you can calculate. Here, ma? So this is. You will get the option 1. Check it whether you are getting it or not. The volatility of HF is low because of HF molecule will form which one? Hydrogen. But volatility means what? They can easily evaporate. Liquid easily evaporate. That will be called as a volatility. But HF molecule, low volatility. Why? Because among the HF molecule, hydrogen bonding will be there. If bond attractions are more, volatile will be less. So what should be our answer here? Because it is having strong hydrogen bonding. Option 4 is the answer. Stronger the hydrogen bonding, evaporation will be less, volatile will be less. So this is the option 4 is the answer.
ఆపలేదా మీరు